Okay, so let's talk about spinal nerves and how they're set up. So they're set up very similar to muscles. So we've got big groups, which are separated into smaller groups, which are separated into the smallest groups. So you guys recall around the spinal cord and around the brain, we've got meninges, and they're separated into dura mater. Remember this? Dura mater, and then we've got subdural space, and then we've got an arachnoid mater, and then we've got a pia mater, right, up against the spinal column. So if you remember, we've got the epidural space, we've got the dura mater, the subdural space, the arachnoid mater, the subarachnoid space, and then the pia mater. Okay, so not super important. That's background. But remember what we said, that those meningeal layers, they are continuous with the spinal nerve. So what happens is we've got our dorsal rootlets. Remember this? Our dorsal rootlets are going to come off the spinal cord, and they're going to become the dorsal root, right? And then they're going to combine with the ventral rootlets with the ventral root, and then that's going to become the spinal nerve, right? That's going to become the spinal nerve, and that is going to exit through the intervertebral foramen, okay? It's going to exit. Now we're going to pick up where it comes out of the intervertebral foramen, okay? So this, what I'm saying is this layer right here, this meningeal layer is continuous with this meningeal layer, with these meningeal layers, okay? So, and that's what I'm going to pick up. So now we're coming out of the spinal cord. I'm just going to do, so we've got our intervertebral foramen, like that. So now it's coming out, okay, like that, okay? That layer, now that it's out here, that layer around the outside of that, that's going to be called the epineurium. E-P-I-N-E-U-R-I-U-M. Epineurium. Okay? That's the layer around the spinal nerve. Now I'm going to make it bigger. Okay? I'm going to blow her up here a little bit. Okay? So just remember, this is where I'm at. Okay? I'm going to erase this now, and I'll make it bigger so we can get some detail. But everybody understands where in the body we're talking about. Here comes the spinal cord. The whole spinal cord is coming down like this, right? This is coming from around the back. So that's the dorsal root. It's coming around the front. That's the ventral root. Okay? It should be going like that. Ventral root. Okay? And they're going to come together. So this is motor. This is sensory. This is mixed. Okay? So we're right here. So I'm going to erase this, and I'm going to draw this part right here a little bit bigger. Okay. All right, so we've got there's our intervertebral foramen. Here comes our spinal nerve. Okay. Now I'm going to kind of cut it. You got to cut it. Cut. Okay, so now I've got a cross section of it there. Okay. This, right here, this is the spinal nerve. I cut it with a scalpel or something, right? This membrane around the whole outside of it, that is the epineurium. The epineurium. Okay? Inside of the epineurium, this is all full of loose connective tissue. Okay? Inside of this matrix of loose connective tissue, this isn't a good circle and it's bothering me, hold on. Inside of this matrix of loose connective tissue, that's better. Inside this matrix of loose connective tissue, this is where the axons are, right? This is where the axons are. The axons aren't just flying around here in random orientations, okay? They're contained within something called fascicles. So inside of here, there's other membranes like this. And inside of those will be the axons. Okay? This is called a fascicle. Let me make this a little bit more 3D. All right? These are coming out like that. So this, that's a fascicle. Okay? The fascicle is defined by the membrane that is its covering, is its perimeter, and that's called the perineurium. Okay? The perineurium. And there's a whole bunch of these in there, a whole bunch of fascicles going through a spinal nerve. All right? Like that. Okay, a whole bunch of these in here. And I'll make one more that's bigger than all these. Okay? Also in here, we've got blood vessels. So we've got veins. We've got veins in there. All right? We've got veins all over the place in there. And then we've also got arteries in here. All right? And this is to supply these nerves with blood. All right? So we've got blood vessels. We've got arteries, and we've got veins in there. Okay? Now let's take a closer. Oh, there's also adipose in here too. There's fat in here too. I'll draw some fat. Okay, adipose. And adipose is loose connective tissue, so adipose. Okay. Now let's take a look at one of these fascicles. Okay, let's take a look at one of these fascicles. So let's say we've got a fascicle that's coming out here. I'll make it a little bit bigger. A little fascicle coming out here. Okay, inside the fascicle, there are all sorts of axons in there. Let's take one of those axons and kind of bring her out and make it bigger. Okay. Does anybody remember what glial cell is responsible for myelinating peripheral nerves, so spinal nerves? You remember that? What glial cell? I'll give you a multiple choice. It's either oligodendrocytes. I didn't have a chat screen up. Oligodendrocytes or Schwann cells. Which one would that be?
Oligodendrocytes.
Close.
Crap.
Schwann cells. So these are Schwann cells. Oligodendrocytes are found within the central nervous system. Schwann cells are found outside. Okay, these are myelinations. So remember, does anyone remember what the spaces in between the internodes or Schwann cells are called? Remember this? Remember, saltatory conduction happens here. Jumps. Right, the signal is jumping. Saltatory conduction. So it doesn't have to open all the sodium ion channels. It can just jump over a bunch. So these are our internodes. This is an internode, and that's a Schwann cell. Right? These are Schwann cells, make our internodes. And then in between them, where the signals, the action potential actually jumps, those are called nodes of Renvier. Right? Nodes of Renvier. Okay. Now, so this is one axon coming out. All right. Now here's where we solve a little bit of a problem. So we know that the action potentials are jumping, right? Saltatory conduction, jumping from node to node. But we need something to keep the action potential from this axon to jumping to its neighbor, right? From keeping the action potential, the charge difference, from opening voltage-gated ion channels on an adjacent axon. And so there's another membrane that surrounds each and every axon. Okay? Each and every axon has another membrane around it to keep the action potentials contained. Okay? Like this. Like that. Okay. And that is called an endoneurium. Endoneurium. Okay, that's an endoneurium. So, we've got epineurium, which surrounds the spinal nerve. Epineurium surrounds the spinal nerve. Right? Within the epineurium, we've got loose connective tissue. Loose connective tissue is kind of the matrix that's keeping all this stuff in place. And what is keeping in place are fascicles, which have a membrane around them called a perineurium. Within the fascicles, right? Within the fascicles, there are other membranes surrounding each and every axon, and those are called endoneurium. So an endoneurium surrounds an axon, which is located in a fascicle, which is defined by its perineurium, which sits in loose connective tissue that's defined by the epineurium. Okay? Or, going superficial to deep, epineurium, loose connective tissue, perineurium, right? Perineurium, and then endoneurium, and then axon. Okay? Good there? Any questions about that? Okay, I'm going to go back on to the PowerPoint now. I'm going to shut the video off here.